Hello everyone, this is Miss James. I am making this little video which is going to be an example of a screencast formatted conclusion. And it's going to be on the Pinhole Lab. So I've also put up the grading sheet. You can feel free to do this as you're doing your screencast as well, so that I can make sure to hit each one of these things, and as I'm talking about it I will try to remember to highlight it. This is the same data section as the sample data section, and screencasts typically should be 3 to 5 minutes. If it gets over 5 minutes, it could come with a grading penalty because it's important to be succinct. Okay, so here we go. Hi, my name is Miss James, and I'm here today to talk to you about the scientific question, how does object distance affect image height in a pinhole camera? Okay, if we look at the data, we can see that as the object distance increased, the image height decreased. And in fact, we could develop a formula to predict the image height, which is image height equals object height times image distance divided by object distance, or high equals ho die over dough. On the screen, you will see the data tables and graphs. Let's take a moment to consider the data table. So as the object distance increased from 3 to 12, the image height started at 10.2, but then decreased quite rapidly to only 2.4. That backs up our result that as the object distance increased, the image height decreased. Then we can also turn to the graph. In the graph, you have object distance on the x-axis and image height on the y, and you notice that downward negative slope. That downward negative slope is telling you, as the object distance goes up, the image distance goes down. Okay, so if we look at this graph, we can actually develop this formula. So when we did similar triangles, we found that the ratio of high is to ho is the same as die is to dough. And when we solve that for high, we get high equals ho die over dough. So if that formula actually works, we should see that ho times die equals high. Well, on our table we see that ho equals 2.5 and die equals 12. So if I multiply those together, I get 30. 30 looks an awful lot like 31. Therefore, our equation is a success. In fact, we could do a percent difference, and our percent difference would be the difference, 31 minus 30, which equals 1, and divided by what we expect, which is 30, and we would find that the percentage is a mere 3%, which is fabulous. That same level of percent difference is also apparent in our table, where we used high equals ho die over dough to calculate what high should be according to this formula and compared it to what we got data-wise. And you could see our highest percent difference is a mere 5% and our lowest is 2, and on average is just about 3%. So that gives us great confidence in our formula. Another way to look at how close the two are is this graph. This is something that I would only expect Accelerated to do, but you can graph the measured image height versus the calculated image height. And you would hope for a slope to be exactly 1, so that y, calculated, equals x, measured. And in fact, we get pretty close. We get 0.98, which is 2% off. Fabulous. Okay, so we've done the advanced analysis. Now we need to explain why this result makes sense. This result makes sense. To understand it, you have to look at a diagram. And I went on the internet and I found a nice little simulator. Now let's look at what happens. This is a high DO, right? This is DO, the object distance, and this is the image height. As I move this in, notice that this angle is getting bigger, which makes that angle get bigger, which makes this image get bigger. So for small DOs, we have these big angles. As we pull the object out, those angles get much smaller. And when they get smaller, so does the image height. Now we want to talk about sources of error. The sources of error have to likely do with both measurement and placement. Was DI constant the whole time? Did we measure HO properly? That sort of thing. And then finally, for future research, I need something new to vary. So since I kept object height constant, I'm going to choose next time to see how object height affects image height. Thank you very much. I hope this really helped you to understand how a screencast should be. Thanks so much for listening. Bye.